data lakes and file formats today. So let's dig into it. So the main things we're going to be talking about today are: one, what is a data lake? Two, what is compression? Compression is like this magical thing where it's like, wow, the data is now smaller, but like, what causes the data to actually be smaller? That's the thing that's like, some people might not understand what actually happens underneath the hood there. We're going to go into some rather intricate detail about compression, so you can understand more around what is actually happening underneath the hood when compression is happening. And then we're going to be talking about how Parquet file format is amazing. I use Parquet in particularly at Netflix and Airbnb. Parquet was what we love to use a lot. And the last thing we're going to be talking about is why should we partition our data sets? And partitioning data sets, especially on date, is a very, very powerful thing that allows your data and the data in your data lake to be a lot more manageable. So yeah, let's dig into it. So what is a data lake? Simply put, a data lake is a set of files on someone else's computer, whether that be Jeff Bezos's computer or Satya Nadella's computer or what Sergey Brin's computer. Like most of the time, one of y'all is the data lake is usually a bunch of files in the cloud, and usually it's going to either be on AWS, Azure, or GCP. It's going to be some sort of cloud compute way of doing things. And those are going to be kind of like the data lake way of doing things. Obviously, there was like in the past, they had like Hadoop, and you could do your old kind of like setting it up yourself and having like the replication factors and all that stuff. But nowadays, you can think of it as a data lake is a set of files in the cloud. And it's really that straightforward. But then it's like one of the things that with this definition that trips people up a lot is there's no constraints. It's just a bunch of files in the cloud. So it's like, it's not like Postgres in that way. And it's not like a data warehouse in that way, in that like you can literally put whatever the hell you want. And that's why like with the data lake, like new paradigm and the new data lake paradigm, what we want to be doing differently is having some sort of wrapper on top. So the three big competitors in that space right now is you have Apache Iceberg, you have Delta Lake, and you have Huddy. Those are going to be the three kind of competitors in the abstraction on top of the files in the cloud, so that it's not just like a data swamp. Because I think that that's a very common thing that happens, is because there is no constraints on the files that you put in the cloud, people just put whatever the hell they want in the cloud and put whatever the hell they want in the lake. And then the quality goes down, and then you have all sorts of other problems that can happen when you aren't managing your data lake correctly. But remember, there's nothing magical about a data lake. It literally is everyone's renting Jeff Bezos's computer, and we just put our data on Jeff Bezos's computer. That's literally all it is. Let's go to the next slide. So what is compression? So compression is a way of reducing the size of data. And generally speaking, there's two types of compression. You have lossy and lossless compression. So in the data engineering space, lossy compression is just not the way to go, because what you get in compression gains, you lose in quality. Because now what if the data is just wrong when you decompress it because the data is a little bit different? Lossy compression is a lot more common when you're like streaming analog data or like, in video. I'm sure all of you have tried to send a text message with an image on it, and then that image went across the SMS, and then it was just absolutely trash. Because SMS, when you send an image across SMS, it's a lossy compression algorithm. So a lot of the details of your image gets lost, and like you can kind of still make it out, but it's bad. And so the lossy compression algorithms are all over on the internet, especially when you're talking about like rich media, like video, image, audio processing, in those areas where like you have a lot of like dead space in the video that can be compressed down. But a lot of times those are like, that's just how it works. But like when you're working with data like that and it's like a video, a lot of the time, like you don't need that to be the highest quality, because you're just watching the video. You're not really making a ton of decisions off of it, right? But then there's also another type of compression called lossless. Now, lossless compression is really, really awesome. So lossless compression is a way that you can reduce your data size without losing anything. There's no drawback to lossless compression. And that's what we're going to be mostly focusing on today in the lab and also in this presentation. Lossy compression is not as important for data engineering. So remember, you should only be using lossless. Don't use lossy compression. It's not worth it. But with lossless compression, you can Google it. If you Google lossless compression techniques, there's like 12 or 13 of them. There's really only one that matters at all in data engineering, and that's going to be run length encoding. Run length encoding is super powerful, and it's one of those things that is supported by Parquet file format and a couple of the other ones. I don't know if you've heard of ORC, like optimized row columnar format. Both of those support run length encoding, and run length encoding is, in my opinion, the most important and powerful aspect of Parquet file format. We're going to be talking more about some of the massive wins that I got at Airbnb leveraging this compression technique. So yeah, let's dig a little bit deeper. So how does run length encoding work? So run length encoding works by compressing data that is repeated. So imagine if you have a bunch of repeated data, then what will happen is it will just not repeat it, and it will just nullify the values that are repeated, and then it shrinks the data set quite dramatically. So imagine we had this table. It's called likes by country and gender, and we have a date, a country, a gender, and the number of likes that were in that country and gender on that date. So imagine we had this data set, and let's go over to another slide here. So data in this data set might look something like this, where you have 2024, January 1st, US male, number of likes. And one of the key things I want you to think about here is you see on the left side of that data set, you see how like we have 4 2024 0101s repeated. And then we also, after that, we have US repeated twice and India repeated twice. So this is a very, very common thing that happens in data sets when you have repeated data, especially when you're building like OLAP cubes that have like where you cut by a couple dimensions at the same time, because then you have all the combinations of those dimensions, and then the combinations will compress differently. So what does run length encoding do to this data set to compress it? So what it does essentially is you'll see everything that has a strike through. What it does is Parquet file format and run length encoding will null those out and remove that data. And then at the top of each one, so you see this 2024-0101, it will say 4. So that means that we have 4 in a row of that one. And then the rest of these dates are nullified, and that data is removed from the data set. So it dramatically reduces the data set volume. And you'll see with like the US, so we have a run of 2 here. We have US and US, and then we say 2 because, again, we can save some space there, even when the streak is only too long. Obviously, like if you have a streak of 1, run length encoding doesn't work. It doesn't do anything. So one of the most important things that you got to remember when you want to leverage run length encoding to compress your data sets is, how is your data sorted, right? Because sorting is what's going to matter the most. Because if we sorted differently, if we sorted this data set differently, we might get different compression, and the streaks would look differently, right? Because imagine if instead we sorted on gender. Gender might actually be better here, because then all the males will be together and all the females, and there's only like a couple values that are even possible for gender. So you think about like when a dimension has a low cardinality, that is going to be where you want to sort on that column first and then go down the line. And that's how you can get the best compression. And we're going to be going over that deeply in the lab today. So make sure you get a dataexpert.io account so that we can get ready to do all this stuff. So one of the things, the key thing here that I want you to see is the more repeated values in the data set, the more savings that you get. So how much run length encoding actually compresses your data set really does depend on the data set. where some data sets might see like a 10 or 20 or 30% compression gain. Others are going to see a dramatically higher compression gain. It really just depends on how many repeated values and how you sort your data. So yeah, let's go to the next slide. So remember, when you're sorting your data, you want to your data needs to be sorted by lowest cardinality to highest cardinality dimensions. That's going to be how you can really get the best compression. So I want to talk about an example here that I did at Airbnb. So one of my data sets that I had at Airbnb was for availability, and what it was it had a listing, and then it had 400 rows for the next 400 days of availability. So it's like you have the listing ID, the date, and then there's 400 rows for every listing ID. So you could imagine if we made sure that all the listings were grouped together, all of those listing IDs would be compressed down. They would all be compressed down into like just one ID, right? Because you would have 400 repeated values. And so, and all of those would roll up into one value. And so one of the things I noticed was that like, just by adding literally one line of code, and it was just a sort, all it was a little sort line of code to the availability data set. It went from being 10 gigabytes to being 0.3 gigabytes. And so that was a massive, massive win for Airbnb in terms of space, because it's 10 gigabytes a day, and they needed to hold on to the history over many, many years, over a decade of time. They needed to hold on to those 10 gigabytes a day. But now it's like more than 10x savings, right? Like it was like a 95% reduction in size, even more than that. And so one of the things that this allowed Airbnb to do was all the pipelines that depended on this data set, they started running a lot faster. They started having a lot fewer errors because the data set is just a lot more compressed, and because of how run length encoding works. So keeping in mind that run length encoding does not apply to all file formats. That's something that's important to remember. So like, for example, if you have your data lake and you're just throwing CSV files into your data lake, guess what? There's nothing you can do. Like the 10 gigabytes, like the sorting, there's no run length encoding in CSV. So you can't use CSV. CSV is kind of a dumb data type. I don't really like it as much because it doesn't leverage any of these compression things at all. So we're going to go a little bit deeper here to talk more about Parquet specifically, because that's a very, very important part of your data lake formatting. So let's go to the next slide. So why should we use Parquet? So Parquet really has a couple benefits. The biggest one that I just hammered into y'all's skull is run length encoding. So run length encoding is going to be the biggest benefit that you get from using Parquet. Another one that's also very, very good is it's columnar instead of row oriented. Whereas CSV files are row oriented, and I just hate row oriented data storage. Row oriented is don't like it, especially for data lake. It's row oriented is a little bit better in like the transactional Postgres, like relational database world. There it's like a little bit better, but like in this world, like in the data lake world, you better be using columnar, because columnar is going to be way better. And here's why columnar is better. So imagine you are looking at this data set, and this data set has 10 columns, but you only need 2 of the columns. So if it's columnar, you can just select those 2 columns, and then the other 8 will just be ignored. And you don't have to read in the data. They're just left. The data is just left, and you don't have to, it's not read in. You just ignore those columns, and you just select the data that you need, as opposed to all of the data. And so when you write your data in Parquet format, it allows the consumer of your data to just select the data that they need, as opposed to selecting all of the data. And so this can make the analysis dramatically quicker, like dramatically quicker, depending on like how many columns they're selecting and what they're counting by and aggregating by. Because then when you're selecting the right columns, bada bing, bada boom, you're good to go. And it minimizes the amount of data that you actually read. Because keeping in mind that when you think about cloud cost, right? There's a couple different ways to think about cloud costs when you're working in the data lake world. One is the cost to hold on to data on Jeff Bezos's computer. So like S3 storage cost, that's one. S3 storage cost is actually pretty damn cheap. Even a petabyte, whatever, like even that's pretty reasonably priced. So storage is actually pretty cheap. EC2, like which is going to be your compute when you're actually running your compute instances, that is a little bit more expensive. But there's one area in cloud cost that is the most expensive, and that's going to be ingress and egress costs of reading data out of S3 and writing data to S3. That is going to be where you get the biggest freaking like penalty in terms of cost. Like, so, you know, in the example that I gave where I got that massive savings for the availability data set at Airbnb, most of that savings was not in storage because that's just like one data set. Because where we got the big savings is that there were hundreds of pipelines that read in that data set. So instead of reading in 10 gigabytes a day, now it's reading in 0.3 gigabytes a day. And then that's times 100 or 200, however many downstream pipelines there are. And then that's the thing you got to remember as a data engineer is a lot of the times when you're creating data sets, like it's not about the storage. It's not even about the compute to generate the data set. It's about how is this data set read? How is this data set consumed? Is it consumed by other pipelines? Is it consumed by analysts? All of those things. And it's like, if you have a data set that's consumed by analysts, it better be columnar. Like have a columnar data set that your analyst is querying, because it's like, then they get to decide how much data they consume. And then you minimize the ingress and egress costs of reading and writing data from S3. So that's why columnar data is just the way to go. It's amazing. And obviously run length encoding, really, really good. The last thing I would want to say is it's everywhere. Parquet is what I used exclusively at Netflix and Airbnb. Facebook was interesting. At Facebook, there was like the big debate about whether or not to use ORC or Parquet. There was like a big battle. And like ORC, I used ORC more than Parquet at Facebook, but that was also a really long time ago. That was like 8 years ago. So Parquet has gotten a lot more adoption, and I bet it has more adoption at Facebook now as well. So anyways, that is going to be how Parquet is just so good. Okay. Let's talk a little bit about partitioning. Partitioning is another very important concept in the data lake world. So remember, we said that a data lake is just files on somebody else's computer. That's all it is. That's all it is. So partitioning is putting folders for those files. It's giving those files some structure. So it's not just like you have this one big beefy file that has all of the data and you just have to always play with this gigantic file every time. You can put that file into different folders, and then that allows you to select just the data that you need. Usually this is based on time. So we're going to go over a really solid example in the lab today over like how partitioning is really, really powerful on like what it will do to minimize the data that you consume. So keeping in mind all of this stuff together is going to be what contributes to data minimization, right? So columnar, you minimize the columns. Run length encoding, you minimize the amount of data that's being read in. And partitioning is you minimize the number of rows that is being read in. And so that's what partitioning is going to do. So you use if you use all three of these concepts together, that's when your analysts are going to be very happy with your data lake performance and your cloud costs, all of that stuff. So a key thing to remember here about partitioning is it's usually the case that your data is going to be partitioned on date, like some sort of time dimension is going to be the most common way that your data is partitioned, but not always. That's not always the only partitioning. Another great example is if you have another dimension that's kind of low cardinality, you can put that one in there as well. Like for example, when I worked at Facebook, we would partition all the notification data would be partitioned on date, but it would also be partitioned on channel. So then, like, if you wanted to read the SMS notifications without having to read all the push notifications, you could look at just SMS and it would be fast. Or email notifications and not push, or just push, right? You can just pick and choose. If there is another kind of obvious logical grouping that you want to use for partitioning, that's another very powerful way to go. So some things I want to caution y'all about with partitioning is you don't want to partition on a column that is high cardinality. Like if your column is like an ID, like a user ID or like a listing ID, anything that has like millions or tens of thousands of cardinality, you don't want to partition on that. That's gonna create way too many folders, and that's gonna cause S3 to have a different problem. So what happens in that case when you have too many files and too many folders is S3. There's a very expensive operation in S3 called file list. And so what file list does is it asks S3, give me all of the files that are a part of this, right? Give me all the files that are a part of Jeff Bezos's computer. And if you have all these folders, then that can take a long time. And then that can be that file list operation can then be the bottleneck for your queries if you partition too much. So that's the thing about partitioning. There is like not partitioning is bad because then you have like one gigantic file that is kind of hard to work with. Partitioning too much has a different problem because then you have too many small files that you're working with that causes a different set of problems. So you want to be kind of in the middle ground there where it's like maybe like one folder per day, and then maybe adding one other thing, especially if you have a large amount of data, then adding another partition there. Keeping in mind when you partition on more than one column, that the second column is called a sub partition, just to kind of give you the lingo of like how things are actually said and how things are working. So that is essentially what I wanted to cover in today's presentation. And so we are going to be transitioning over to the lab here in just a second. So let's go to the last slide of this. So what we're going to do in the lab today is we're going to be covering run length encoding, data lake compression with Trino, and make sure you have a dataexpert.io account and then log in. You got to be logged in and then go to dataexpert.io/classroom/Zach Wilson. And that's where you can follow along live and you can get notifications of all the queries that I run so that you can kind of catch up and you can stay up with me. So here, we're going to switch over here to that window now. Let's go with, yeah, there we go. I think, 1 second, I just want to get this to focus. Can we get that to focus? Okay, there we go. That's focused. So now what we have here is we're going to be working with this classroom. I just want to go over the classroom and how this works because we will be creating data sets today. And if you don't follow the instructions the right way here, you will not be able to create data sets. So when you create data sets in dataexpert.io, you have to create them inside of your schema. And your schema is based on the username that you picked when you made your account. And so for me, I have Zach Wilson as my username. And so what we're going to do is we're mostly going to be working with NBA game details and NBA games. Those are going to be the two big tables that we're going to be working with today. So one of the things I want to show y'all is what happens when we run this query. So I'm going to just run to see like, what does NBA game details look like? So this is the create table statement. So you'll see here it is. And keeping in mind, this is a data lake that is managed by Apache Iceberg. So Iceberg is the metadata layer here that manages all of this data. And you'll see here is our table. It has a bunch of columns, big int, varchar, all that kind of stuff. And you'll see it is a Parquet format. One of the things you might notice here is this table is not partitioned. It's not partitioned at all. So what we want to do here is let's go ahead and create another table here that is partitioned. And we're going to partition it on season because I think season is a good column to partition this on. But one of the things you might notice here is season is actually not a column in this table. You'll see there's another table here called NBA games, and that's where we're going to have that. So the idea here is we're going to try out a couple different compression techniques, and we're going to be creating a new schema here. So we're going to say create table, and I'm going to call this Zach Wilson. I'm going to call this NBA game details. I'm going to call this NBA game details sorted. So for your table, make sure that this is your username so that you can actually play along here. So then we can say player name is going to be a varchar. We're not going to like do all of these columns because that's like a pain. But what we can do here is we have player name. And then I think another column here that would be useful is team abbreviation. I like team abbreviation. That can be a varchar. And then let's go ahead and get the kind of the points and the metric columns. So we're going to say points as a double. We're going to say rebounds as a double. We're going to say steals as a double. We're going to say assists as a double, right? Because like I know these are actually integers, but like they're stored as doubles in here. So we're going to keep them as doubles. And so now what we have is we're getting there, but we need a couple other things in here. We're going to need game ID, and game ID in this case is a big int. And then we're going to need season, which is an integer. And then we also have game date, which is a date. And then, so this is going to be our starting kind of table that we're going to be working with. But now we need to specify that it's Parquet. So if you use with here, that's how you can specify kind of the table formatting. So in this case, we say format equals, we can say Parquet. And then we want to say partitioning equals. And then how partitioning works is it's an array. We specify it as an array of values. And then inside of this array, we put the values that we care about. So in this case, we're just going to partition on season. And then the last one we want to do here is we're going to sort. So we have to specify how we're sorting this table. I personally like sorting. I think the right way to do this is we should sort by player name and game date. I think that's probably going to be a very good way to sort this data. But we are going to compare. We're going to compare like sorted versus unsorted, all that kind of stuff. So now this is a pretty solid query. I think that we can run with this. So you'll see you'll get a notification here that of the what I actually ran. And so now we have access to this table, right? This table just got created. So now what we want to do is we need to get all of these columns, right? So if we say like select star from bootcamp.nba game details, and we're going to call this GD, and then we need to get that season and game date columns, and those are in Bootcamp NBA games. So let's go ahead and join here. We're going to say bootcamp.nba games G, and this is going to be on gd.gameid equals g.gameid. So now the goal here is we're just trying to get all of these columns, right? So first we got to do gd.playername, gd.team abbreviation. Then we have points. So in this case, it's GD points is just PTS, and we're going to call this as points. Then we have GD dot, what's reb? Is it just reb? Okay, it's reb as rebounds. And then we have steals, GD dot steal as steals. And then assists, GD dot assist as assists. Then what else we got? Game ID. So this is going to be gd.gameid. Then we have season. So season's actually coming from the other table. We have that in the games table. And then one of the things that you'll see is in this Bootcamp NBA games, one of the things I want to show y'all real quick is how this editor kind of works. So if I say like select star from NBA games like this, I can actually run the selection. So we can actually see what the hell is in that table. So we don't have to like make assumptions. And you'll see here we have game date EST. So that's what we're going to want to do, but we're going to wrap that. So we're going to say date, and we're going to say g.game date EST as game date. Because I think EST is a stupid thing to put in there. So now this is going to be a pretty good representation of what we're trying to do here. So if we run this, you'll see this should give us essentially the table format that we're looking for. You'll see it's not really sorted, but that's fine because the sorting will happen on write. So now what we want to do is we're going to take NBA game details and we're going to say insert into Zach Wilson NBA game details sorted, and then we're just gonna run this guy. So now this is gonna run, and we'll be able to get our sorted data. Okay, so that just created 669,000 rows of data. So this is obviously not the smallest data set in the world, right? It's actually, we're getting pretty big here. So now what I want to show y'all is if we say select star from, we're just gonna select star from this guy real quick, and we're gonna read in this this table here. Okay, so you see now how it's like Aaron Brooks, Aaron Brooks, Aaron Brooks, Aaron Brooks, and it's like it's sorted, right, by all of his games in a row, and then Aaron Gray, Aaron Gray, Aaron Gray, right? So you have all of them sorted in a row, but you'll see it's actually only like 2007 because remember we're partitioning on season, so it's not like all of their games in a row. It's just all of their games in that one season in a row. So one of the things I want to show you is we made a very big difference compared to this old bootcamp NBA games details table and this current one. So I want to show you how to do this in Iceberg. So in Iceberg, what you can do is there's a special thing here where you can actually query the files that were actually created, where what you do is you wrap it in quotes and then you put $files at the end of the table name. And then that allows you to actually see the data that was created here. So you'll see here are all of the Parquet files. See, here's the 2022 season, 2021 or 2012 season, and the Parquet file where it is sitting. So this is, remember, this is just Jeff Bezos's computer, right? And then we're sitting in this folder and then all of these additional folders, right? And you'll see that partitioning, what it does is it creates another layer of a folder here. That's what it does. So I want to compare that and let y'all see. So if we say select star from, and then we say bootcamp.nba game details, but then we put this in quotes, and then we say $files, this is going to be a significantly fewer number of files because we don't have that partitioning. So you'll see it's literally one file. It's just one big ass file at this location. You'll see in here, you see how there's no folder in here, no additional like season equals folder. It's just like, here is your gigantic 600,000 row Parquet file. Have fun, bro. Right. And you'll see with Iceberg and all this stuff, you get a lot of very interesting data. Right. So you see, for example, here we have record count and then the file size in bytes. So one of the things that is going to be happening here is now that our data is sorted, this file size in bytes is going to be a lot smaller overall. So you'll see here what we got. Well, what we're going to do is we're going to call this sum file size in bytes, right? And then we're going to call this a new. And then here we're going to say old sum file size in bytes. And then we're going to call this as bytes. This is as bytes. Then we want to say union all here. Obviously, we didn't keep all of the columns, but you'll see here we can look and we can actually compare and contrast all of them together, right? So you'll see in this case, like we are dramatically lower here. Obviously, we didn't select all the columns, so we did also lose some data there. But that's what I want to illustrate to y'all next is I want to show you how sorting actually does make a difference. So what we're going to do now is we're going to go up to this NBA game details sorted, and we're going to make a new table here called NBA game details unsorted. And the only thing we're going to do is we're going to remove this sorted by attribute, and the rest of this is going to be exactly the same. So then what we're going to do is we're going to create this table that does not have the nice sort value, right? So now what we can do is we can very easily copy that data, and we can do this insert query again very, very quickly, right? So now this is going to run, and we're going to write a billion trillion rows into the data lake, and then you'll see how that like works in terms of building out a lot of stuff. So you see here now we wrote all the data here. So now in this case, I want to query all of the files but I'm going to do this as unsorted. So this is unsorted and this is sorted. So this is going to show you how much we save. Remember, like what I was talking about with run length encoding. Run length encoding and sorting is very, very connected. So let's see how much we save when we sort our data set. Oh, this is Zach Wilson. That's why. Zach Wilson, not boot camp. So now this is going to show us. So you see, we got a little tiny bit of savings here. And so that might be an indicator to us that there might be a better way to sort the data than what we currently are doing. That is one potential possibility. But you see that in this case, the unsorted data is actually, it's saying is actually smaller. And so one of the reasons for why that could be the case is if we sort by player name, we might be exploding another column here. And that's actually what's going on. So let's go ahead and query that data set real quick. So if we say select star from, let's see what this actually looks like. What is the unsorted data look like here? So interesting. Generally speaking, this okay. So you'll see here. I think what happened is in this case we have this player. Okay, then we have game ID and season. Those actually should be like, that's very, very interesting that actually didn't do what I wanted. Let's okay, so what I think happened here in this case is the sorting is it's actually, the compression here is happening because of the fact that the natural order of the data is actually better at compressing it than sorting it, which the only way that would happen is if there is some sort of column in here where there's like a lot of people who have a lot of zeros, right? You see all these people who have a lot of zeros and they're like clustered together. All the people with zeros are clustered together. And that would mean that these columns are all all these double columns are, all these zeros are clustered together. So that's one way that you can see that sometimes when you sort things, it can actually make the data bigger because these zeros are all like they're more clustered together in this case than they are with when you sort by player name. So if we go into like how that works, right? Let's go ahead and try one more example here where let's do let's call this sorted, and then we're gonna say we're gonna call this sorted points. So in this case, all we're going to do is we're going to say sorted by equals array. And we're just going to sort on points here to see what that does, right? Because one of the whole things here that I'm trying to illustrate to y'all as data engineers is it's very common that when you are working with things and especially when you're working with these optimization problems, you can get unexpected values here. So an unexpected results. So if we go ahead and run this sorted points, this is going to give us a new kind of thing where I think what this will do is this is going to give us what we would expect, hopefully. And that will kind of like, because run length encoding is what this is all about, right? Okay, there we go. So now let's look at sorted points. So if we say we're going to add sorted points to the files here, we're going to compare the two file sizes in bytes. Okay, so you see, there we go. The natural order of the data there was really strange. So this is illustrating it better so that you can kind of see when that was like not sorting it at all. That was like a fluke. But you see here, like if you, depending on how you sort the data, you get a very big difference in the file size. So, and that was like the natural order of this data is very strange. And I want to learn more about like what's going on there. But like, you'll see here, this is going to be, we're going to call this, this is sorted by points, and this is sorted by player name, right? Let's rerun this query so that that's like more obvious because it's not actually unsorted. No, that's not what I ran. Wow, let's make that go away. And then, so if we run this selection here, there we go. Now this will be sorted by player name and sorted by points. So you'll see now we can see, okay, we have sorted by player name, sorted by points, and you see when we sort by player name, we get dramatically different size in the data. And this comes back to the run length encoding that is inherent with Parquet file format. So that's essentially what we're trying to do here, is trying to find the optimum sorting for the data set. And this is and so that we can compress it down and make it as small as possible. So that is going to be the main way that you can get some very big wins when you're working with Parquet file format. So the other thing I wanted to show y'all is, like, so now we have this NBA game details sorted. Let's go ahead and I want to show you another really cool thing you can do with Trino. So you can say show stats for, and then what if we say, we're going to say select star, and we're going to say from Zach Wilson.NBA game details sorted where season equals 2022. So if we run this query, this is a great way to see how much data is scanned. So you'll see here, this is saying we are, this is how much of each column that we're going to be scanning is, right? And the distinct values. That's interesting that these are all null. Some of this is null because of the fact that it didn't like register all of the data sizes, because these are all like integers and stuff, whereas this is a string. These are strings. So one of the things you can see is we have a partition here, right? But then if we say bootcamp NBA game details, oh, this doesn't have season though, but like if we run this, you'll see this one is going to have significantly more, right? You see this, the data volumes and data sizes can be very much larger, right? And that's a very common thing that can happen when you are working with different data sets. When you're wanting to like understand how much IO is happening for your data, this is a great way to do it, is like with show stats for, because this is going to show you exactly how many bytes is like actually coming through when you're reading this data set. So that's going to be another great example of where you can show how partitioning is going to help a lot. Like, so I wanted to go over one more example here, because I think that there is another example here that is probably better that will illustrate this again, because I don't want to confuse y'all in terms of like what happened there with like some of the sorting. But we're going to actually look at this other table here called actor films. So if we look at bootcamp actor films, this table is pretty cool. So in here you have like an actor, you have a film, you have a year. So this table is partitioned on year. So one of the things I wanted to do though is I wanted to compare two different ways that this could work, right? Because you can see how you can sort on film or you can sort on actor, right? You could, which one comes first? So let's go ahead and create another table here. We're going to call this Zach Wilson. We're going to call this actor films sorted. And then this is going to be, we're going to have an actor varchar. We have a film varchar. And we have a year, which is an integer. And then really, I don't want the rest of those columns. I think that that's all we really want. And then in this case, we're going to say width, and we're going to say format equals Parquet. And then we have partitioning is still the same, right? Where we have a year as the partitioning. And then in this case, we're going to say sorted by, and then the array here, we want to try actor and then film. But we also want to, so I'm going to say this is going to get sorted by actor. We're going to create two tables here real quick. We're going to create this table. And then this one's very easy to like insert into, right? So, okay, so we did that one. So we say insert into this table. Then we're going to say select actor film year from bootcamp.actorfilms. So this is just going to show you like, okay, is there more? A great way to think about this is like to sort by actor or film first is like, are there more actors per film, or are there more films per actor? That's the question that you want to be thinking about here. My guess is that there's more actors per film, but like I think that it really depends. I think that there's definitely going to be some that are going to be the other way around, but like, so we're going to do sorted by actor, and then we're going to sort by film as well. So we're going to say sorted by film, where in that case, what we're going to do is we're going to sort by film and then actor. And then we'll see which one actually is the better way to go, because I think this really illustrates what the cardinality looks like between the two, right? So there we go. And then we just want to do sorted by film. We're going to insert that into the data set here. Oh, did I not? I forgot to actually run the selection. So there we go. We are running that selection now. Now we will get our kind of our data sets, and we can see. So now if we let's just look at select star from this guy, but we're gonna be going back into the files, right? Just so we can kind of understand what is going on here, and then let's just do the whole thing. We can say file size in bytes, right? And then we want to do another one here, and this is sorted by actor. We say union all, and then this is say by film, and then this one here is by actor, and then we can then run this to see what is the better way to sort, right? Because one of these is probably the better way to sort. So you'll see in this case, it doesn't matter that much, but because if you think about it, like it probably makes sense where like the average actor probably has 20 or 30 films throughout their career, whereas the average film probably has 20 to 30 actors. That's why this is very, very close, right? These are actually like the compression gains that you get, whether you sort by film or whether you sort by actor. It doesn't matter that much. So that's a good sign that but you see that like my initial hunch there of like sorting by actor, like that like if you sorted by film, you would get a little bit more compression. So that was correct, right? But like this is the idea behind like how if you want to manage your data and you want to do things the right way, like you need to be thinking about this stuff. Like the number of data engineers who think about this is very, very, very low. Most people think they just write their damn SQL and they just are like, okay, I wrote my insert into, I wrote my create table, and that's it. Now I'm done. But that's not like, as data engineers, we need to be caring about efficiency. Did y'all know that like the amount of carbon that's produced by all of data processing is like 4 or 5% of like all the carbon, right, that we produce? It's some very, very high percent of the economy that we should be working on. And this is a great way to minimize the set. So I'm going to take a pause here, and I'm going to actually go and look at some comments and to see like what's going on in the chat here. So anyways, I'm going to be taking some questions from y'all. If y'all have any questions on this stuff, on also, I'm running a boot camp that starts in May, and it's going to be really awesome. And that's going to be another great place to learn a lot more about this in depth, as opposed to just these kind of like 1 hour sessions where we kind of go back and forth. But one of the things I wanted to show real quick here is if you want to join my bootcamp and get a good discount, if you do early bird V4 at checkout, you'll get 20% off, and that will be pretty awesome. So that can be another great way to get more savings. And then so this will make it 1,600 to join, which is cheaper than all of my other boot camps. Like all of them, it'll be the best value that you can get. But definitely, we got a question. Sorting queries, even in a CTE, make it more efficient. No, you like a lot of the times, like the sorting really should only happen at the very end. The sort should happen on write, not any other time. Because if you can do the sort on write, that is when you're going to get the most savings without a lot of the other minuses of like, because a lot of times sorting like inside the query is going to be kind of painful, because like you'll sort it and then you'll join. And then if you join, shuffle happens. And then all of the sorting that you just did is gone, right? It's gone, right? Because just shuffle happened, bada bing, bada boom, right? So, yeah, this is going to be essentially like how a lot of this works. But I'm definitely down for like another like probably another like 5-ish minutes to answer any other kind of questions y'all have, whether it be about data lakes, dataexpert.io, data engineer, the boot camp, anything like that. I'm really here for y'all to like really answer any questions. I'm really grateful for y'all showing up to this live today. I feel very humbled and very happy that we were able to get over 100 people in at the same time. At what file size do you think you should remove a partition? Say you have year, month, day, hour, minute. At what point do you remove the minute or even hour? So like I've never ever seen a table freaking partitioned on hour or on minute. Minute is insane. Partitioning your data on minute is absolutely bananas. Generally speaking, in big tech, like 95% of your data sets are partitioned on date, like just date. And then some of them are partitioned on date and hour. It's not really about data volume here that really determines how you want to partition it. It's more about like data like getting access patterns, right? Because most people are going to want to look at one day of data. It's not really about volume, right? The volume doesn't determine whether you partition. It's like, how are people querying and using this data? And a lot of times that's like they want to look at one day of data. It's all about like your partitioning should be informed based on how your analysts run their where statements, right? That's going to be the biggest thing, is like, what is the where clause that's happening? Because partition pruning and predicate pushdown is what happens to make your queries a lot faster, because then you ignore a lot of the other data that's working, right? So someone said, is asking Delta format versus Parquet, which one is better? It's the same. It's so similar that they're the same. Like I would not say that like it's the same. Like Delta, Iceberg, and Huddy, it's the same. Like it's all the same. Like at Netflix, Airbnb, Facebook, how do analytics engineers use Python? They use it to build pipelines. They use it to define metrics. 1 second, my freaking camera is. I'm trying to like figure out this camera has like this weird autofocus problem. I'm trying to figure it out, but analytics engineers, they write it to do data models, to write pipelines, Airflow code, all that kind of stuff, right? Oh, there we go. Okay, that's good. And so that's what I would say. Yeah, definitely. Okay, so on the topic of partitioning, when date is preferred, but a date time is the only column in the table, is it worth processing cost of adding a date field, then partitioning on that? Actually, you know what's really cool about Iceberg is that you don't have to add another column for the partitioning. So like, for example, like if you wanted to create a table, so I'm just going to create some random table here. We're just going to say test. And then I'm going to say we're going to have a column here, test varchar. And then we have another column here, event timestamp, which is a timestamp, right? And then we can do our little width here. And then we can say partitioning equals, and then array. And then you can say inside of here, you can say day of event timestamp. So you can actually partition. So like, you're totally right. It's very, very common that you don't have like a date column. So there's 2 ways to do this. Like one is you can add a date column and make that one way to do it. Another way to do it is you can do it this way. I think it's actually days. I want to say it's days. Let's run this query real quick. I got to put the format in there. So we say format equals Parquet, and then we have that. Let's see. I think this query should run. It will yell at me if not. Is it not? Oh, this already exists. I love it. Okay, let's days partitioning. I love how that like already exists. That's my favorite thing in the world. Okay, so I think, okay, so is it day? It must be day. It's just day. There we go. So now you'll see, now this will partition your data by day, but you don't actually have to add that extra day column into the table because you can specify it here. I know that there's probably a way to do that in Delta and Huddy. I don't know how to do that in Delta and Huddy, but I know you can. But this is how you do it in Iceberg, is like you can specify your partitioning with this day column. So if you only have like an hour or minute timestamp, then you can still partition your data that way without having to do some bullshit like adding like event date, and then these two are like the same thing. This is just like a truncated version of this guy, and that's a stupid thing to do, right? Because then you're just adding extra storage space, and that's like not what you want to do, right? That's why partitioning is going to be a better play for sure. We we say here. I got another 2 or 3 minutes here that we can go over things and just kind of like I love talking about this stuff. Like data infrastructure efficiency is probably one of my favorite topics to talk about. Okay, say, but if we have multiple joins on the same sort column, does it make sense to sort in CTE? Great question, Rama. No, actually, again, like the sort does not actually get registered. Like you think it would, and in some cases, like in Spark, right? For example, in Spark, there's a thing called a bucket join. But if you're gonna like that, doesn't happen in memory. Like if you want to leverage sorted columns on join in a data lake environment, obviously, I'm not talking about BigQuery. I'm not talking about Snowflake. Those things have their own thing. I'm talking about just data lake, Delta, Iceberg, Huddy. Like if you're talking about that stuff and you're wanting to do a special optimized sorted join, that needs to happen on write. So like, you know how we did the little sorted by and then we write out the data? That's where Trino and Spark and all these things can leverage that fact, because once the data is in RAM, Spark does not trust that it stays sorted. It only it trusts the partition metadata on whether or not that partition is sorted. That's how it does it, right? What is the difference between categorized partition and run length encoding? They're very different. Run length encoding shrinks the data based on how many values show up in a row, whereas categorized partition is just that's the folders that you put the data into. They both work pretty well at minimizing the data sets that you're trying to create, but like highly recommend learning both of those things if you want to be an efficient data engineer. So we say, what is the best relationship database where these compressions and partitioning makes much benefits, like Oracle or SQL Server or MySQL? Like, I don't know, man. I don't work with that shit. Like, I don't know. Like I mean, all of those are about the same. Like in those cases, you're going to want to leverage indexing and all that stuff. This stuff does not apply as much in that space. That was one of the things I started this presentation with. Like, don't think that this works in relational database world. Don't think that this works in like Snowflake or BigQuery. Some of these concepts are similar in Snowflake and BigQuery, but they're different as well. Like this is more like, this is all about Jeff Bezos's computer and putting files on Jeff Bezos's computer and leveraging that. That is where you get the biggest bang for your buck is there. So let's check if I understood it well. Run length and your optimization is about writing data, which I have to partition and sort the data. When we are reading data, it should skip sorting data, right? Yeah, for sure. Because Murillo, the data is already sorted. It's sorted on write. You don't have to worry about sorting it again because it's already sorted. It's not just sorted, but like the partition metadata tells the processor that it's sorted. And that partition metadata is something that the processors can trust. So that is one of the best ways to do it, right? What is the best way to learn distributed compute? Joining my bootcamp, and because we cover all of this stuff in a lot of detail. So that is the best way to learn distributed compute. And I'm going to be covering a lot more sessions on distributed compute, Trino, query plans, optimization, skew. Every time 5 to 6 p.m. Pacific, I'm going to be doing these lives consistently over the next long time. Like, so just like, there's also all this free content that I'm giving y'all for free. But if you want more in-depth content that's more than 1 hour a week, then I highly, highly, highly recommend that you join my bootcamp. And I'm going to put this last one more time here before we go. So if you do early bird V4 at checkout, you get 20% off, but you have to do it by February 9th, right? February 9th. You have till next Friday, right? That's when you can you can join and you can be a part of the community. And that's when we do 8 hours a week of technical discussions like this for freaking 6 weeks. And then we talk data quality, distributed compute, data modeling, all of it. And so definitely that's going to be probably one of your best ways to do it. And awesome, everyone. Thank you so much for joining my stream today. I really, really appreciate it. I am really excited for where things are going to go with this stuff. But I hope that y'all have a fantastic Thursday and happy February.